Having seen deadlock prevention in the previous class, now we move on to the next topic, which is nothing but deadlock detection. Now, in the previous classes, we have already seen the prevention methods and we have even gone through the avoidance method. Now, I assume we have not taken any measures, or let us take a real time example where even though you have a symptoms, you haven't taken any medicine for your headache or fever. So, obviously, you get the fever, right? So, similarly, in this, we haven't gone for prevention measures and we have even not taken any measures for avoiding. So, what you get a deadlock. But how do we go for detecting that particular deadlock? So, the first step here is deadlock detection. You know that deadlock has occurred, but we have to detect. So when you want to detect a deadlock here, we have to take into two consideration. One is single instance, other is multiple instance. So when you go for your single instance here, we go for using a graph which is known as wait for graph. And in the graph, if you are able to get a cycle, then you say that there is a deadlock. And when you go for your multiple instance, we go for using a safety algorithm, or you can even call it as a detection algorithm for detecting that the deadlock has occurred. Now we'll just see an example of a wait for graph. So before moving on to see what is a wait for graph, this is a sample resource allocation graph. So when you see the resource allocation graph, you already know that these are your resources, these are your process, and these are nothing but your edges, right? Now, if you want to convert this wait resource allocation graph into your wait for graph, you just check the your resources will not be available in the wait for graph. You only have the process. So if you have an edge from P1 to P2, so then just see the link from P1 to R1, you have a link, and R1 to P2. So what you do is you need to collapse these edges and remove the resource. So when I remove all these things, you directly establish a link from P1 to P2. So here you got from P1 to P2. Similarly, when you see this P2 to R4 and R4 to P3. So what I do, I remove all these things. So you have an edge from P2 to P3. Similarly, when you go for this P3 to P4, P3 to P4, you just remove this particular resource and you have an edge from P3 to P4. Similarly, you have an edge from P2 to P1, and you have a resource, you have an edge from, if I remove this R3, you have an edge from P2 to P5. So this is what a wait for graph is. So a wait for graph will have only have the process without any resources. Now you check whether there are any cycles in it. Now when you just see this P1 to P2, P2 to P3, P3 to P4, and again you are coming back to P1. So here you have a cycle. So since you have a cycle here, you said that there is a deadlock. So you have detected a deadlock here. But this will be useful only for your single instance of the resources. Now when you go for multiple instances, so when you have your multiple instances, we go for using an algorithm which is nothing but deadlock detection algorithm. And the first two steps are same. You initialize your work is equal to available, right? And finish of I. Here the only change is you just check your allocation matrix, and if any of the allocation value is equal to 0, then the finish of I value will be true. Otherwise, you initialize all your finish of I equal to false. Now for each of the process, you check whether the finish of I is equal to false and your request is less than or equal to your work. You are comparing it to your work. Previously, you were comparing this with your need, but here we'll compare only with the work. And if you are able to satisfy this condition, you change your work and make your finish of I is equal to true. And if all the finish of I is equal to true, then you say that there is a deadlock, is in a deadlock state, is not equal to true for a, sorry, if your finish of I is not equal to true for some particular thing, you say the system is in a deadlock state. And if finish of I is equal to true, then you say the system is in a safe state. Now we'll see an example here. So you'll be provided with allocation matrix, request matrix, and the available values which will be given to you. Previously in safety, we have calculated need, but here there is no need of calculating your need. You only have to make your work is equal to available. So what will be your initial work value? It is equal to 000. And you need to even initialize your finish value, finish of equal to number of process here. So it is 1, 2, 3, and 4. You check whether any of your allocation is equal to 0. If allocation is equal to 0, this is true. So since any of your allocation is not true, your finish matrix values will be initially false. Now We'll start with the resource P naught. So when you're starting with your resource, what is the condition I need to check? Request of 0 less than or equal to work. What is your request value? 0, 0, 0. What is your work? 0, 0, 0. It is less than. So you're satisfying the condition. Only change you need to do is work is equal to work plus allocation. What is your allocation value of P naught? 0, 1, 0. What is your current work value? 0, 0, 0 plus 0, 1, 0, which will be your current new work value is 0, 1, 0. And since it is satisfying the condition, you make your finish of that particular process is equal to true and add P naught to your sequence. Move on to your next process. So what is your next process now? What is your request here? 202. What is your work value? 010. So what is your request value here? Here we'll go for checking it. Request value, request 1. What is your request 1 here? 202. 202 is not less than 010. It is less than or equal to 202. Is it less than or equal to 010? No. So you will not touch it. You go to your next process. Next process is P2. So when you are going for P2, now you are at P2. So what is your value here? Your request value is 000. So when you have your 00 value, 010 is your work and request value is 000 is less than or equal to 010. Yes, it is, the condition is satisfied. Now you have to make the necessary changes. So what is your work value? 010 plus what is the allocation value of it? 303, which is 313. You must make P2 to be added into your sequence. Now since P2 is done, we'll move on to the next one, P3. So P3, what is your request value? 100. So 100 is it less than or equal to your work value? What is your updated work value? Updated work value here is nothing but 313. Since it is less than, again you make your work value change. 313 plus what is your allocation value here? 211. So 313 plus 211, which is nothing but 524. So make the corresponding finish value as also true. Now, since it's also been added to your sequence, now you have P0, P2, P3. Now, the next process will be moving on this P4. So, what is your request value here? 000. So, 000 is 002 is less than 524. Again, you make the corresponding changes. 524 plus what is your allocation value? 002. So, it becomes 526 and your finish matrix is equal to true and you add the sequence. Now, since you have done with P1, P2, P3, you check whether any of the process is left out. You couldn't allocate it for P0. So now you couldn't allocate it for P1, sorry. So now you again repeat for P1. P1 request. What is the request of P1? 202. So since 202 is less than your work value is 526. 202 less than or equal to 526. Yes, you change your corresponding allocation value. Allocation value would be 526 plus what is your allocation value here? 200. So you get this. So you have a save sequence here. So since all the finish values are true, it indicates that the system is in safe state, means the deadlock has not occurred. Now we'll just see a situation where your system will not be in a safe state. I assume this is the thing. And here we go for a particular request where P2 initially the request of it was 000 in the previous example. Now it wants one instance of this P2 C resources. So it is 001. Now if you are able to do it, now we'll check whether the request can be granted or not. So we'll again check the process from P0. So what is your initial value of work is equal to 000 and finish of I is also equal to 0. So you start with request of 0, which is 0 less than or equal to work, yes, and you update your allocation work accordingly. 000 plus what is the allocation here? These two values to be summed up and you get a value as 010. Now your current work is 010. So again go for P1. What is the request? This is your allocation, this is your request, and this is your available. So next request is 202. What is the work? 010. So 202. So 202 less than or equal to 010 is false. So you move on to the next one where it is 001. Request 3 less than or equal to 010. It is also false. Request 3 is 100. less than or equal to, all the three values should be less than, right? So this is also false. Request for 002 less than or equal to 010, this is also false. So here other than p naught you are not able to satisfy, and even if you go back to again p naught, you are not able to get all the conditions as true. So this means it is the unsafe state. So if you are getting a sequence, if you are not getting a sequence here, then it is an unsafe state and you say that there is a deadlock. Now, we have seen how to detect the deadlock. Now, when do you actually go for invoking this particular deadlock? So you have two options. One is every time whenever a request is made, you have to invoke this detection algorithm. Advantages, it is very easy to find, and after you know that which process has been deadlock, you will be able to preempt that particular resource. You will be knowing which process has been caused the deadlock. But the disadvantage is every time whenever a process is requesting, you have to go through that particular algorithm, which involves more amount of computation time. So to avoid this particular problem of every time, what we do is we fix up a time. At least for every 1 hour or every 2 hours, you run this detection algorithm. But if you are fixing up this time, you may get a situation, but within that particular duration, it might have caused already a deadlock. So that may be the problem. Now, we'll move on to the next one. Now you have detected a deadlock. You know that there is a deadlock. What is the next thing that you have to do? You need to go for making a recovery measure. So what are the recovery measures? One is in terms of process, the other in terms of resources. So when you go for a process, because the deadlock is occurring because of these process and resources only, right? So what we do is we either go for aborting all the deadlock process which are involved in that particular cycle, or you abort one process at a time until you are able to come out of the deadlock. And when you are going for the resources, you either take away all the resources, preempt the resources, take away the resources, or you roll back to a situation where you were in the safe state. So when I go for a process, for example, so in order to abort a particular process, you have to take all these things into the consideration. How long the process was computed and how much of the process has finished the work. What is the priority of that process? And when I am aborting a process, how many resources are held with that particular process? And how many total process are to be required. So all these factors are to be considered when you want to abort a particular process or all the process in order to recover from the deadlock. The other situation can be, as I told you, we'll only rely upon the resource where we go for preempting. Now when I want to preempt, you act for, first of all, select which is the resource that is to be, you have to preempt, meaning that from a particular process you have to take away the resource. So which process? And you have to see that every time you don't select the same process for taking away the resource, so it leads to starvation. Or else the other issue we have to deal is rollback. So at what point of time you should again go back to the computation and start it. So these are the things which are to be taken care when you are going for your recovery. So in this today's session, we have seen how to detect a deadlock, what are the algorithm that is being used for single instance as well as your multiple instance, and how to recover from a deadlock. We'll continue with the next session in the next class.